Lesson 5.4. It's all about what we call polygons, plane figures. So lots to write down here. Let's get going right away. These are two-dimensional shapes. That's why we call them plane figures. Doesn't mean that they are ordinary, but just that they lie on a plane. First of all, a couple of important C words. Number one, plane figures, polygons, are closed. They're not open. And they are convex, not concave. The next two descriptions are a little trickier. Those, by the way, are the two main ones. So don't forget those. These two are harder to describe, but hang with me. Consecutive sides intersect at the endpoints. Intersect at endpoints. Okay? Each vertex belongs to two sides exactly. And I'll show you examples of what each of those descriptions there means. Before we do that though, how do we name these shapes? Okay? Number one, name them by going either clockwise or counterclockwise. And don't skip any vertices. Again, a vertice is a corner. Yeah, fancy word for corner. So, here we have a polygon. Or is it? Actually, it's not. But if it were a polygon, you could name this HGFE. Again, or you could start with G and go HEF. A lot of different starting places, 4 different spots, 2 different directions. So there's 8 ways to name that. But unfortunately, this is not. And hopefully you can see that this is concave. Yes? It goes in there. It is also, one side is not a segment. So HG is not a segment. That should have been put up here. All sides are segments. Let's add that to that. All sides are segments. Okay. Here we have a scenario where it's not necessarily concave, A, B, C, D, E, but we have rule, the third one, consecutive sides intersect at endpoints. So here we have a side, yeah, and here we have a side, yeah, and they intersect at more than just the endpoints. And so that's a problem, okay? Those sides cannot intersect except at the endpoints. Here we have, now if you were talking about this PRO, prom K, that would be a polygon. But there is a segment in there, PR, PO, that if that's included as part of the polygon, then it's not part of it. Okay, that's a really rare instance that's talked about. Finally, TVS, not finally, but next to last, TVSY is a polygon, but TVSYX is not, because this is collinear with YT, and so X is not a vertex, so you can't use that. So that's part of what that last, each vertex belongs to 2 sides exactly. Okay. And here we have a case where this polygon is not closed. Yeah, there's that gap there, kind of obvious. So here we have some shapes. we're going to be talking about four-sided shapes, namely the ones that are here. This is a polygon, very famous. This is, but this is not a polygon. Alrighty. One thing about convex polygons, by the way, you can also speak of concave polygons, but interior angles are less than 180 degrees. All right, and you can see there that that angle on the interior at, you could call it A, is more than 180 degrees. We will be talking about diagonals inside of polygons, and diagonals are segments that join non-consecutive vertices. Yeah, so we'll draw the famous pentagon, and if I go from A to B, that's not a diagonal, right? These are the boundaries of the polygon. But if I go from A to C, that's a diagonal. If I go from A to D, that is a diagonal. Again, A to E is not, because that's a side. So non-consecutive, right? B and E are consecutive to A. Finally, here are the, I think, 6 shapes. And I'm going to highlight it with a diagram in each case. Parallelogram, most famous. Both pairs of opposite sides are parallel. So what I like to do is sketch that and then put in little parallel symbols. Make sure that you use double ones on one side and singles on the other. Rectangle, kind of odd definition. It's a parallelogram with at least one right angle. Now, if you put one right angle in there, say there, then it ends up that all the angles end up to be right angles. And so I don't know why they said at least one. Don't sweat that. If you say all 4, it's true too. One common misconception is that kids think the width cannot equal the length to be a rectangle, and that is false, meaning a square can also be thought of as a rectangle. Caution on that. Rhombus, a parallelogram with at least 2 consecutive sides congruent. So if it's a parallelogram, right, those 2 sides will be congruent. Now it ends up that all the sides will be congruent. Much like we have all the angles being congruent. Once you put one of them at a right angle, then they're all. So too in a rhombus, once you make 2 sides, all 4 sides. Kite, disjointed pair. Fancy word. What does that mean? That means that you have a pair here, and it's not joined to this pair here. All right? Finally, I guess you would say that the square is the most popular of parallel four-sided quadrilaterals. Okay? It is the most precise and it is the strict. So a square is composed of these 3 characteristics. Opposite sides are parallel, angles are 90 degrees, and all consecutive sides are congruent. Okay? Trapezoid. Exactly, yes? Exactly 1 pair. You can't have 2 pairs. So here are my pair of parallel sides. Trapezoid. And then finally we have a, like, you can think of this as not item 7, but 6 prime, an isosceles trapezoid. In an isosceles trapezoid, we have not only the pair of parallel sides, but then the other sides are congruent. All right? And then we refer to the bottom angles as the base angles. So here's the base angles, and here are the upper base angles. All right. Well, there's your homework. Hopefully you can get through those problems in 5.5, getting familiar, 5.4, excuse me, with four-sided polygons.